When we think of the solar system, we tend to assume that it ends at the last planet.
In reality, the sun's influence extends almost 11 billion miles away, far beyond the planets and even past the Kuiper Belt.
But what's there? Let's take a look. Simply put, there is a huge bubble surrounding our solar system created by the sun's magnetic field called the heliosphere. As the heliosphere moves through the Milky Way, it shields the solar system from harmful cosmic rays, a form of interstellar radiation.
What we usually think of as empty space between the planets is actually filled with charged particles flowing from the sun. The sun sends this particle flow, called solar wind, out in all directions until it reaches the termination shock, where it slows down as it starts to feel the opposing interstellar wind. It continues through the heliosheath, and the solar wind piles up against the interstellar wind. Once it reaches the heliopause, the solar wind bends back and flows down to the other end of the heliosphere. A bow shock forms in front of the heliosphere as it travels through interstellar space, similar to how a bow wave forms when a boat moves through the water. You can think of it as a spaceship that protects the solar system as it cruises through the galaxy. It is generally believed to have a smooth comet shape, but recent research suggests that it may look like a croissant instead.
But how exactly are we able to visualize this? First, we need to understand the behavior of the sun.
Approximately every 11 years, the sun goes through the solar cycle, where its magnetic field flips from north to south and vice versa during the next cycle. The changing magnetic field causes shifts in the activity of the sun, affecting the solar wind patterns as well.
On October 19, 2008, NASA launched the Interstellar Boundary Explorer, or IBEX for short, which has been observing the boundary of the heliosphere since it was put into Earth's orbit. To understand how it functions, imagine a bat in the dark.
The bat uses echolocation to navigate, sending out high-frequency sound waves and using the echoes of its calls to locate its prey.
Similarly, the IBEX detects the return signals from the solar wind when it hits the boundary of the heliosphere.
At the peak of the solar cycle, solar wind increases dramatically. The charged particles in the solar wind collide with neutral atoms from interstellar gas, creating energetic neutral atoms, or ENA, which are then detected by the IBEX. The time it takes for the return signal to be detected, usually ranging from 2 to 6 years, determines the distance to the region where the ENAs originated. Using this method, the IBEX took a photo of the heliosphere with data from a whole solar cycle, one particle at a time.
But instead of using light, it played a game of connect the dots on a massive 3-dimensional level. Everything that we've learned so far about the heliosphere and its interaction with the interstellar medium are just the beginning of our discoveries.
Astrophysicists are currently uncovering the mysteries of the heliosphere, and the knowledge we gain from this exploration can help us map out our location in the galaxy, understand how the heliosphere influences life on Earth, and even possibly find the right conditions for life on planets orbiting other stars.
By doing this, we are taking a huge step towards revealing more about the wonders of our universe, and it is so exciting to anticipate the new discoveries that we will make in the future.